We start off Chapter 3 by looking at how we select the appropriate numerical summaries. When describing these numerical data sets, we usually will report both a value that describes the center along with a value that describes how much variability or spread there is. So we're going to have measures of center and measures of variability in this chapter. The center is describing where that data distribution is located on a number line, and you can think of this as a typical value. Whereas the measure of variability is just looking at how much variability there is in that distribution. It basically measures how much individual values differ from one another. If your distribution is symmetric, then you're going to report the mean and the standard deviation. So in Chapter 2, we talked about that idea of symmetric being where if you were to draw a vertical line, both sides of the distribution would look similar. If you have skewed distribution or if there are some outliers, then you should use the median and the interquartile range. The reason that we do that is the mean and the standard deviation are calculated in such a way that each individual value is included in the calculation for the mean and the standard deviation. So when you have a few values that are very different from the rest of the values, they're going to end up putting a lot of weight towards them and making the mean not reflect what most of the data set looks like. Whereas for the median and the interquartile range, the outliers are not directly involved in the calculation for the median. And we'll see here in a minute how we calculate the mean and the median, and so you'll see why those outliers don't affect the median, but they would affect the mean. So if we look at an example of the rates of medication errors among depressed and burnout residents, they looked at 24 residents in pediatric who were classified as depressed based on their score on the Harvard National Depression Screening Scale. They then looked at the patient medical records to see if there were errors in ordering or administering medications. Here's the data, and we see that most of these residents did not have any errors. There were a few residents that had 1, 2, or 3. We had one resident with 5 and one resident with 11. So if we were to look at the mean, what would happen is we would assume that as a group, these residents were performing a good number of errors, whereas it really was just these 2 residents that were behaving differently from the rest of the group. Here's another example looking at baseball player salaries at the beginning of each season. So this is the 2016 salaries for the Kansas City Royals. These are given in millions of dollars just to make the numbers simpler. We'll see that there are a few athletes that are making a lot of money. I mean, anybody making anywhere close to these amounts of money are making a lot of money. But within the context of the rest of them, there are a few that are making a lot more than the others. We can plot this and we see that most of the athletes are earning about $1 to $2 million. There's a few in the middle range, they're around 6 or 7 million. And then we have this one player who's earning almost $14 million. So if we were to calculate the mean, we would have to include that high value. And that's going to pull the average towards that high value, making it look like the baseball players were earning a lot more than they typically were. So we would use the median here so that we would truly just get the middle number, and that would be more reflective of a data set that's skewed like this one.